Hello again. Today we are going to talk about linear inequalities and solving systems of linear inequalities. So just as a quick review, if I have these two problems right here, I have an equation. It's an equal sign, x plus 5. So something added 5 to it. So some number, if I add 5, I get 8. So I can undo, subtract 5 on both sides, and I figure out that number is 3. 3 is the only number that if I add 5, I will get 8. So there's one solution. So graphically, I'd have a number line, and at 3, I plot my point. Okay, it's an included point, so it's a closed circle. And then if I want to write it in interval notation, there's no interval. It's just the number 3 as the solution. Versus if I have the inequality, x plus 5 is less than 8. I solve it the same way as the equation, except now I get a range of values. Any number that's less than 3, plug it in, and I get a true statement. So graphing that, I'd have an open circle, and then I'd shade everything to the left. So 2, 1, 0, 1.5. Those numbers that are all less than 3 would be solutions. So then writing this solution in interval notation, okay, we're going to the left. Okay, we can go forever. So we're going to negative infinity. We use parentheses around infinity because it's a concept, not a number that we can plug in. And then 3, we'd also have parentheses around that because it's not included. If I plug in 3, 3 plus 5 is 8, which is not less than 8. All right, so we get as close to 3 as possible. So 2.99 would be a solution, but 3 would not be. All right, so this is when we're just working with one variable. All right, so we just have one number line. But if we have two variables, we have to have the two number lines. We're going to be graphing, okay, we're going to be graphing these linear inequalities. So the steps for this is you're going to rewrite your equations with an equal sign. You're going to first graph what's called the boundary line. Okay, then if it's not solved for y, you're going to solve for y. Or you can use intercepts. If it's in standard form and it has nice integer intercepts, you can use intercepts. Okay, you need to graph that line. Only difference is for an inequality, okay, that's going to give you the boundary. Then you have to shade the region where your solutions are going to lie. So the boundary line may or may not be included. If it is not included, it's going to be a dashed line, just like if you'd have an open circle for the less than or just the greater than. Open circle, in this case it's going to be a dashed line. And then if the boundary line is included or equal to, that means that you're going to have a solid line. Okay, any point on the boundary line would be a part of your solution. And then you have to pick, are you going to shade to which side of that boundary line? So pick an ordered pair that is not, key part of this is it can't be on the boundary line. Plug it into the original inequality, and if it's true, you're going to shade over the ordered pair, and it's false, you're going to shade on the opposite side of that line. All right, so a couple of examples here. So I'm going to rewrite my inequality as an equal. So y equals, and then negative x plus 3. So this tells me my slope, when I compare this to y equals mx plus b, m is in front of x, so that would be negative 1 over 1. And the y-intercept is positive 3. All right, so over here, first I'd need to draw in axes. So I'd draw in an x-axis, and I would draw in a y-axis. And then what I would do is the m tells you how to move. You need to know where you're moving. You need to have a starting point. So b is that starting point. So at positive 3, you'd plot your point on that y-axis. And then the slope tells you how to move, so from that point we go down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. And you can plot as many points that you have for your graph, and then if you have a straight edge, you can connect. Now, before you just connect those without thinking, are these points included? So this was or equal to, which means that these points that are on this boundary line are solutions, so that means I'm going to have a solid line. So I would connect these with a solid line. All right, now, not only are these points a part of the solution, okay, but I'm also going to have points off the line that are part of the solution. They're either going to be in this half of the graph or in this half of the graph. I need to figure out which one, so I'm going to choose what's called a test point. And you get to pick any point, any one that you want, as long as it's not on the boundary line. So the most common one to use is the origin, 0, 0. And plug it into the original inequality. So here's the x, here's the y. So I'm going to replace y with 0 is less than or equal to negative x, so negative 0 plus 3. All right, so this gives me 0 is less than or equal to negative 0 is just 0, plus 3 is 3. 0 is less than or equal to 3. Yes, it's true. 0 is less than 3. So this is true. So it's because it's true. Here's where my test point was. I'm going to shade on the side where my test point was. So that means 0, 0 is a solution. It means negative 0, negative 9 would be a solution. Any point that's in the shaded region, plug it in, and you're going to get a true statement into that inequality. All right, so it's not just one solution. Right? So solving equations, you get the one solution. Solving inequalities, you get a range of solutions. All right, so in a second example of this, once again, 2x minus 4y, replace the inequality with an equal sign. Graph the boundary line first. All right, so you can either solve for y or you can use your intercepts. Okay, so since it's in standard form, I'm going to practice using my intercepts. So in order to find an x-intercept, remember that you let y equal 0. So that would give me 2x minus 4 times 0 equals 8. What that means is the y term goes away. It cancels out. So this is going to leave me with 2x equals 8. So divide both sides by 2, and I get x equals 4. So my x-intercept, so on the x-axis, I plot a point at 4. So that would be the ordered pair 4, 0. For the y-intercept, you let the x value equal 0. So 2, replace x with 0, minus 4 times y equals 8. Again, the x value goes away, the x term. That leaves me with negative 4y equals 8. It's being multiplied. Y is being multiplied by negative 4, so the opposite of multiply would be divide both sides by negative 4, and we get y equals negative 2. So the y-intercept would be at 0, negative 2. So I need to graph this line. So I need axes in order to graph that line. So I'll put in my x-axis and a y-axis. And the x-intercept is at 4. Remember, this is the x-axis, so at 1, 2, 3, 4, I would plot a point. The y-intercept is down at negative 2. So here's the y-axis. I go down 2, and then I would connect. I can also figure out the slope. So I went up 1, 2, to the right, 1, 2, 3, 4. So I can go up 2 to the right 4 again. Right? Well, going up 2 and to the right 4, that can be reduced. 2 over 4 is up 1 over 2. So up 1 to the right 2, up 1 to the right 2, up 1 to the right 2, or down 1 to the left 2, down 1 to the left 2, down 1 to the left 2, down 1 to the left 2. Before you connect all of those, ask yourself, is this going to be solid or dashed? And because it is just a less than symbol, it means that these points give the boundary. We get as close to this as possible, but they're not actually included. So we need to make sure that we are using a dashed line. All right, so right now we don't have any solutions. Okay? We have nothing that's included because a dashed line means that those are not points that would satisfy this inequality. So we need to shade. Inequalities, you have to remember to shade. So we're either going to shade up or we're going to shade down. How you decide is pick a test point. Again, pick any point that's not on the boundary line. If 0, 0 is not on the boundary line, use that. It's the easiest. Don't have to, but it is the easiest in my opinion. All right, because when I plug in 0, that's going to leave me with 0 over here. 2 times 0 minus 4 times 0, that's 0. So is 0 less than 8 true or false? Once again, it is true. So here's where the test point was. We're going to shade above our boundary line. So 0, 0 is a solution. 0, 4 would be a solution. Negative 2, 0 would be a solution. Negative 1, 1 would be a solution. Right? But 4, 0 is not a solution. Okay? Because 4, 0 is on the boundary line and it's dashed, so it's not a part of the solution. All right, so that's graphing linear inequalities one at a time. But what if we have a system of linear inequalities? Basically do the exact same thing except for, okay, the hard part's going to be deciding where are you going to shade. So first thing that you need to do is get those boundary lines. All right, so our first line is 2x minus y. I'll replace the inequality with equals 3. All right, if I cover this up, if I want to do intercepts, I'm going to get 3 over 2. I don't want to graph 3 over 2 or 1.5. So what I'm going to do is I'm going to solve for y. So I'm going to subtract 2x from both sides. That's going to give me negative y is equal to negative 2x, and that was positive 3, so plus 3. And then I'm going to divide every term by negative 1. So that's going to give me y equals positive 2x and then minus 3. So my slope is positive 2 over 1, and the y-intercept is negative 3. My other line, I have x plus y equals 2. This one would be really easy to get the intercepts. So my x-intercept, when I let y equal 0, was going to give me x equals 2. Because y equals 0 cancels this out, and I'm left with x equals 2, which would be the ordered pair 2, 0. For the y-intercept, we let x equal 0, and that's going to give me y equals 2. So that would be the ordered pair 0, 2. All right, so now what we need to do is we need to graph. So let me get my axes first. And then we're going to graph both of the boundary lines. And then we'll worry about the shading, which is the most difficult part of this, after that. All right, so my first line, we started off at negative 3, so 1, 2, 3 on the y-axis, and then the slope tells you how to move. So we move up 2 to the right 1, up 2 to the right 1. It's a positive slope, so we're going up. Or we could go down 2 to the left 1, down 2 to the left 1. These should all be included in the solution if we were just looking at this inequality by itself, because it says or equal to. So we still need to make a solid line. All right, the other line I'm graphing by using intercepts, by plotting points. So the x-intercept was at 2, 0. Let me grab a different pen for this. All right, so this was at 2, 0. And the y-intercept was at 0, 2. So down 2 to the right 2, that would simplify to 1 over 1. Negative, because we're going down, so down. So I'm just going to go down 1 over 1 each time. Or up 1 to the left 1 each time. All right, now those are not included in the solution to this inequality because it's just less than. So this is giving our boundary. So they're not included. We can get as close to them as possible, but they're not included. So we're going to use a dashed line for this one. All right, now notice that our graph has been divided into 4 regions. We have this region over here on the left, which is region 1. We have this region up top, which is 2. This is region 3, and this is region 4. When you take geometry, you'll learn that 2 lines intersect at a single point, okay, and they create 4 angles. Okay, well, in this graph, they're creating 4 regions. So now we need to figure out which region are we going to shade, 1, 2, 3, or 4. We can only shade one of them. So what I'm going to suggest that you do is pick a test point. Okay. 0, 0, that's my go-to test point, and once again, it is not on the it is not a part of either line, so I'm going to choose that origin. Okay, but with a system, you have more than one line, which means that we're going to have to do this test point more than once. All right, so once again, my test point is 0, 0. So I'm going to plug it into my first line, and just as a reminder, my first line is this line that's going up, it had the positive slope, and it is in purple and it's solid. My second line had the negative slope, and it was not included, those points were, so it's the dashed line. All right, so I'm going to plug it into the first inequality. So that's going to give me 2 times 0 minus 0 is less than or equal to 3. So that gives me 0 is less than or equal to 3, which is true. All right, so that was compared to my purple line. So pretend like this blue line does not exist right now. Okay. So that means it's compared to my purple line. 0, 0 is true. So here's where 0, 0 is. Okay, I know that either my region 1 or region 2 is where I'm going to shade. All right, but now, remember, a system means that you have more than one equation or more than one inequality. Now I need to use my test point for my other inequality. So that inequality was x, so I'm going to replace x with 0 because I'm still using the same test point. Sometimes you'll have to change which test point you used. If you got a false statement, pick a new one. All right, so we have 0 plus y, which is also 0, is less than 2. So 0 is less than 2. That, once again, is true. All right, so because that's true, it was true for both. That means 0, 0, which falls in region 1, we are going to shade region 1. Okay. All right, one last part to these notes, and that's going to be determining, based off of this graph up here, whether or not these points are solutions. So you can either look at the graph to tell, or if you don't have the graph, you can use inequalities. Or if the graph is too difficult to tell, you can plug them into the inequalities. Remember, to be true for a system, it has to be true for both inequalities. So 0, 0, well, we just did that. We got true for both, so that means that this is going to be a solution to the system. So I'm just going to put yes. All right, 0, 2. All right, so here is 0, 2, right here, this point, right here. All right, now, automatically, I can tell you that no, it is not going to be a part of the system because it falls on a dashed line. And in order to be a solution to the system, it has to be true for both inequalities. And because it's on a dashed line, it means it's not included in this inequality. Let's see that algebraically. All right, so 0 is replacing the x, plus replace the y with 2. And then is that less than 2? 2 is less than 2, that's false. All right, so because it's false for at least one of the inequalities, it means that no, this is not a solution to the system of inequalities. Okay, 4, 0. So 1, 2, 3, 4, 0 would fall right here. It's not even in a shaded region, so I already know no from my graph. We can see it algebraically. If I replace x in my first equation with 4, minus replace the y with 0 is less than or equal to 3. This gives me 8 minus 0 is less than or equal to 3. 8 is less than or equal to 3. That's obviously false. So once again, because it's false for one of them, I'm not even going to try the other one because it's not true for the system. 3, 3. So 1, 2, 3, 1, 2, 3, right here. All right, so that point is on a solid line. So your intuition might be to say, okay, it's on a solid line, it's included. However, it's not even bordering one of the shaded regions. All right, so that means that no, this is not. Okay, over here, where it borders a shaded region and it's on a solid line, it would be. But up here, it's not even bordering the shaded region. Okay, and here we can verify that algebraically. If I plug 3, 3 into the second inequality, I get x, I replace with 3, plus I replace the y with 3, is less than 2. 6 is less than 2? No, it's not. That's false. All right. The last one is 0, negative 3. So 0, negative 3, that's this point right here. It's on a solid line, and it also is a boundary for the shaded region. So it's on a solid and it's a boundary. Yes, it's going to be a solution to the system. Let's verify that. So if this is your x-coordinate, here's your y-coordinate, plugging them into the original inequalities. The first inequality was 2x, so that's going to be 2 times 0 minus y, which is negative 3, is less than or equal to 3. So 0 minus negative would be a plus 3, is less than or equal to 3. 3 is less than or equal to 3. That is true because 3 is equal to 3. So because it's true for the first one, now I also have to plug it into the second one. So we're going to get x, but we replace it with 0, plus y, which we replace with negative 3, is less than 2. So 0 plus negative 3 is just negative 3 is less than 2, which is true. So because it's true for both, yes. Graphically, it's because it's bordering a shaded region and it's on a solid boundary line. If it borders, but it's on a dashed boundary line, it's not. If it doesn't border and it's on a solid, it's not. But if it borders and is on a solid line, it is a part of the system.